Hi there. So we're going to talk a little bit about this idea of combining like terms and sort of exactly what that means. So when I say combining like terms, so for example, if I had something like 4 plus 3, right? Those are whole numbers. I could combine those together. You've been doing this for a long time. And I could say that equals 7, okay? I could also, at the same time, if we're thinking a little bit more algebraically, we could think of this in terms of variables. If I had something like 2x plus 3x, we could think about how we could combine those together. Because what 2x really means, 2 times x, that's the same thing as kind of saying like x plus x, right? Oops, x plus x. So if we have 2 x's, that means this would be the same thing as 2 times x. If we have 3 x's, that's really the same thing as saying x plus x plus x. Okay, there's 3 x's. So if we wanted to combine these, we can even think of this as like you've got 2 x's and then you're going to add 3 more x's to it. So in total, you could say this is the same thing. Right? Both of these are the same thing as 5x. So what we're seeing is that we can combine things together. You've been combining regular numbers together for a long time. If we have numbers with variables on them, we can think of that, and you can combine those together too. Where it starts to get confusing is when you start to do combinations of those. Okay, so let's say we had a problem where we had 2x plus 4 plus 3x. So if we want to, and I'll actually add plus 2. So if I wanted to combine these things together, my goal is to kind of simplify this. I want to add the things together that I can. Now, I have 2x plus 4, so we would think initially we want to add those together. But we have to remember that 4 is a known number, but 2x, we don't know what x equals yet. So we can't really add x plus 4 together. However, I do have 3 x's over here. So I know I can add those 2 x's and 3 x's. So we kind of think of these as 4 different parts. Now the commutative property, which we talked about with algebraic properties a while ago, tells us if we're just adding, we can actually change the order of these. So I could just make my life easier. Sometimes I like to rewrite this. 2x plus 3x plus 4 plus 2. All I've done is I've just switched the order of these. If you're just doing addition, you can move any of these chunks around. So now I have 2x plus 3x plus 4 plus 2. Now we saw up here, if I have multiple x's, I can combine those together. So 2 x's plus 3 more x's, that would give us 5 x's. And for whole numbers, we can always add those together because we know what 4 equals, we know what 2 equals. So we have 5x plus 6. And at this point, we can no longer combine any more like terms. There's 5x plus 6. I cannot say that's 11x because, again, I don't know what x equals. These are two different things. So this is one way that we can combine like terms. Now, later on, you will be combining like terms and you would have other things like other types of variables. So you might have something like 5x plus 2y plus 3x plus y plus 7 plus 2, something big and long like that. Now you're going to follow the same simple process where you're going to look for what's similar. Okay, I have 5 x's and I have 3 x's. Now, if I was to list them all out, I could write x and do that and then count how many in total, or I could just add those two quantities together. 5 x's plus 3 x's means we've got 8 x's in total. If we look here for the y's, again, I can't add that. That's different than an x, but I could add the y's together to themselves. 2y plus 1y gives us 3y. And if you have a 7 and a 2, we can add those whole numbers together as well. And so that would give us 9. So all we're doing when we're combining like terms, we're just adding the things that are similar together. Later on, there'll also be things with x squares and things like that. Again, you can only add x squared with x squared. But it's just really looking for what is similar and what can I combine.